All right, so now let's talk about weighted least squares. So weighted least squares is actually a special case of generalized least squares where the errors are uncorrelated. And so now sigma is basically a diagonal matrix, and so that means that the off diagonals are going to be 0, and the diagonals are going to have weights w1 through wn on the diagonal. And so now S is going to be a diagonal matrix as well, and this is going to have the square root of the weights from W1 to Wn on the diagonal. And so using the exact same methods that we've talked about for the generalized least squares, we would regress the square root of Wi yi on the square root of Wi xi. And note, when you're doing this, the column of ones in the design matrix should now be replaced by the square root of Wi. But otherwise, this would perform similarly to kind of the GLS methodology. And so cases with low variability are going to end up getting high weights, and those with high variability are going to end up getting low weights. That's kind of the point of this, is to try to help when you have, so we don't think we have correlated errors, but we might still have a non-constant variance across our results here, which would be of concern. So that's what weighted least squares tries to address. And so essentially, there are different examples of kind of how you would construct these weights. We're going to talk about 3 kind of common ones on how to do this. And so in the first case, you see a positive relationship if you plot the absolute value of the residuals against some predictor. So there's some relationship between your residuals and a predictor x. And so in this case, we think that the errors are proportional to a predictor, which suggests that you should use something like a weight that's maybe the inverse of that predictor. Or another common example is that your outcome y is actually an average across n observations. And so here you might want to weight by n. Or in another example, maybe the observed responses are known to be of varying quality, and so here you might want to use 1 over the variance of yi. And so this would be, if you're in this final case here, you would probably do something like using the residuals to help weight your model. So to do this in R, it's actually quite easy. You don't have to use a different package. You can just use the LM function. And in fact, you can fit it exactly as you normally would. You don't have to calculate S or sigma or anything. You can just do your normal LM y tilde x, set your data, and then you use the weights parameter to set the weight that you've determined. So for example, going back to this, if we end up setting the weight to something like n, you can just plug that in here for weights. So you would create a WTS object in R that just equals n for each of your observations, and you would plug that vector in here.